Hello, welcome to my MyWebUniversity free educational videos. In this video, I'm going to show you the Linux shell scripting with test command, ftest, or comparison with test command line. So the video that you're seeing on the screen, we have already posted some of these videos. You're welcome to watch them. They're about shell or Linux scripting, especially on Ubuntu. And there's a lot of them. So you're welcome to learn Linux shell programming, as well as Apache web server, as well as Python scripting, as well as awk programming, C, C++, and then a number of other ones, especially advanced Linux, Unix scripting, and even for C videos that I have posted already. So you're welcome to watch them online at MyWebUniversity free educational. Please don't forget to like and subscribe so I could improve it based on your needs, and make sure you subscribe as well, so you return the favor, as I'm just doing all this online for free, so you guys could just benefit from it. And on this session, I'm going to show you what I'm going to present to you. So let me just do a slideshow on this one. In this one, we're going to discuss ftest statement. And we already went through fnested on section 4. On section 3, we did f statement, and section 2, we did variables. And then under section 1 was introduction to shell programming, which was corn shell, bourne shell, bash, and then C shell, TC shell, awk, and then Z shells. So in this session, we're going to talk about a bash scripting, which is a superset of corn shell and bourne shell. And we're going to do particularly cover the ftest statement. So we are going to show you the examples, the structure, and the syntax. So in this session, which is ftest statement video number 5, the structure of ftest statement is represent you basically that ftest some Boolean expression. When you're doing ftest, whatever the Boolean operation, which I'm going to show you next, then you do some statement. Those statement could be function calls, could be any command line arguments, any further testing, any nested if statement, any for statement, any statement that is assignment statement, anything could be part of those statements. One or more statements, that's why those 3 dots are there. So this is the syntax when you're doing the ftest statement. Usually you do ftest and then some kind of expression. The expression in this case is -r and then file1.txt, which is saying that if -r, if the file is readable. If the file is readable, then it becomes true, and then the file echo file1.txt is readable, a statement is executed. If the file is not readable, which is like ftest bang -r, if the file is not readable, then you're going to go to the else part. So we will show you those example here. In fact, it just showed up on this page. So the test expression, when we are doing test, ftest, and then followed by an expression, the expression could be any form. For example, if the expression is going to be evaluated here, that is true, then part of the f statement is going to be executed. Otherwise, the else part is executed, or lf part is executed. So in this one, if not expression, this means not, this bang exclamation mark on Linux or Unix, we say this bang, the bang symbol, or the exclamation symbol in front of the expression means negated or not. If it is true, it is false. Not true is false. So if the expression is false, this statement will be executed. And then -a means and. So if expression 1 and expression 2, both of them are becoming true, then the expression will be, both expression are true, then the statement following that one will be executed. And then dash O means or, if expression 1 or expression 2. So in this case, if expression 1 is true, sometimes we call it in computer science programming language, we call it short circuit. So if expression 1 is true, you don't even have to check for the or part of it, because an or statement, one or more of the expression has to be true in order for the second statement to be executed. So if expression 1 is true, or expression 2 is true, or both is true, then the statement is still executed. If either expression 1 or expression 2 is true, or both, in fact, both is also important. So the and is different. The and both of them has to be true. If there's 3 expression, the and all 3 has to be true. And I could show you examples of those ones as well. The dash n shows the string is non-zero, meaning that the string is not empty. The string equivalent to dash n is a string. So dash z, and the length of the string is 0. If you are looking for the string that is empty or 0 byte, then you say dash z, and that not dash z is the negating it, or the dash n string is the negation part of it. And then when you're comparing string 1 with string 2, notice the equal sign here. The equal sign basically is not an assignment statement. This is the only programming language when you're doing comparison, you're not using double string. In every other, and double equal sign. Every other Python programming, C++, C, and other programming languages that you do, you normally, when you compare to a string, you put 2 equal sign in order to say this string on the left is equal to the string on the right. But in shell scripting, 1 equal sign is, and the string comparison is understood to be comparison statement between 2 strings. So it's not an assignment statement. And similarly, the not equal sign, and every programming language use bang equal, which means not equal to. So, and shell programming is the same. The only difference is in shell programming for string, you're using 1 equal sign, like almost as if it's an assignment statement. And so this is not an assignment. When you're comparing 2 string, it will compare those 2 strings. Another difference is that when you're comparing the string variables, you're using the equal sign like that. And then when later on we compare integers, you're using dash EQ for equal, and the dash NQ, the not equal, so on. So this one is equal sign or not equal sign, or less than symbol or greater than symbol, or all for those string. But here the letter are used for integers, dash GE for dash greater or equal to. So integer 1 is greater or equal to integer. Notice that we don't say greater symbol equal. That is for a string. This here is the GE, the character, greater or equal. Similarly for integer 1, greater than, and greater integer 2. And this one is integer 1 is dash LE, means less or equal to. And then the integer 1 is less than integer 2. And then integer 1 is not equal to integer 2. So those are the symbols that you're doing and the Boolean expression for checking on them. And then a file EF, file 2, that's if the same device is used and they have both the same inode number. Inode number is the structure on the file system that maintains all these kind of file information, statistic about the file, who owns it, who, what directory it is it a file, is it a directory, is it symbolic link, is it regular file, is it readable, writable, executable, all that details are written in the inode structure. File 1 is not dash NT file 2. If file 1 is newer in modification time than file 2, newer than. older than -ot, older than file 2. And then -b is if this is a block device. -c is if it's a character file. And -d is a directory. -e if file exists. -f is a regular file. -g is if it's a group ID is set. And similarly for the -g is group effective user ID. And -h is for similar to symbolic link -L. And then the -k is for the sticky bit. Normally the sticky bit are files that are on /tem file system. And so -L is for the symbolic link, as we discussed with -h. I'll show you some example of those ones. -o file exists owned by the effective user ID. -p if it is a pipe file. And then -r if it's readable. -s is if it's the size is greater than 0. A file exists and as a size greater than 0. So if the file is like touched, the size is 0 byte, then -s will return false. So we can do some testing on that as well. File existence is a socket -s uppercase S. And T is for file descriptor. Every file, when you open it, there's a file descriptor, whether it's a standard in, a standard output, or standard error. File descriptor reads and writes from those standard in and standard input and standard output. 0 is a standard in, and then 1 is a standard out, and 2 is a standard error. File exists and a set user ID is set. And W if the file is writable, X is if the file is executable. So those were the syntax. The status code are basically whenever you do some testing, and the status code $? will be pointing to whatever the status is, and then after that one, you either get success when it's equal 0 or failure if it is not there, similar to the if statement that we were discussing. So now it's lab time, or let's do some examples so you understand from command lines how we do f-test there. With that in mind, let me just go back to the terminal, and we welcome you to my MyWebUniversity or my YouTube channel. As you noticed on the YouTube channel, this is my YouTube channel for education videos. Please subscribe and then watch all these videos that I'm posting, as well as the new ones. You will be notified as soon as I post them. So first, let's do what is a test. Test is a command, check file types and compare values. So this is like a command that we are going to run and test for validation of this. So let's clear my screen and say ls-ld star.bash. So notice that last time on section 4, I did run this nested-f.bash, which was Sunday, but now we're running it on today. And then it says it's a weekday, and then it shows that it's already Eastern time, 1:38 a.m., which is Pacific Standard Time is 10:38 p.m. So we have time to just make a nice video for you here. And then this script, if I just look at the content of it, and say cat -n for that file, actually I have to do clear the screen first, and then undo cat and dot and this. So a combination of those two commands clears the screen, and as well as write that one, and it starts right here from the program name and that environment. So that this program basically is just checking whether what the day of the week it is there, and it's doing some nested if statement. And so the reason I'm showing you this is just because we did section 4, which was some other f-test statement, and now we're doing this script, which is f-test.bash. Let's see the content of that script, f-test.bash. This is a smaller script, which I just wrote it now, and then basically I'm declaring a variable called name, and then my YouTube channel, which is my MyWebUniversity for educational videos. So you're welcome to subscribe on that YouTube channel. That's why I gave this name, so you can easily find me on YouTube. But if you say, if the string name, notice the equality symbol here. The equality symbol, we are looking at this variable, and if the variable name is equal Wahidullah Lutfi, then it's gonna just go to the printf statement. The printf statement, if you're using left bracket, right bracket, that syntax is for printf statement section 3, which is for C and C++ programming that you're doing it. For C++, obviously, it is replaced to C out, but you still can use it because the standard I/O is still supported. So for printf statement on section 1, then the syntax is not bracket and no bracket here, and then you could just put it all in within that string, and you can still use the new line characters. And in this case, I'm just saying hello, $name, welcome to our YouTube channel. And if I just run that one, say the name of the script is f-test.bash, then it's gonna just say the string that we passed it on. And then the way it reads it, it makes a new line. This one is going to make a new line here. And then the last two is going to add 2 lines at the end. One right here and 1 line right there. But the rest of them is hello, and then replace the $name to Wahidullah Lutfi, because this variable is assigned to that. And then just have one space here. Welcome to our YouTube channel, MyWebUniversity for educational videos. So it does that one. And the way normally shell scripting works, you're just going to do some kind of variable declaration, and then do some kind of if statement or for statement or while statement, or write some functions, and then do the function and declaration, the function definition, function calls, and then you're using the script. And then if you have to connect to a database, yeah, you are welcome to do that one. Normally, you want to write a Python script or another PHP code or something. Bash and shell scripting allows you to do that one. In fact, back in 20 years ago or 25 years ago, we were all writing database Oracle scripting for Unix to do it within Pro-C and C, C++, and combination with shell, and because Python at that time was non-existent, basically 25 years ago, 30 years ago. So and then PHP did not exist at those ones. All of these ones, Perl, Python, and everything else is introduced. They're great programming language, especially Python. It does so many general purpose programming needs, and as well as you can do data science, you can do artificial intelligence, you can do a lot of different modules with Python, game programming, anything you can name it, you can do with Python. Similarly, you could do it with C, C++, and C allows you more kind of speed as well. But Python was written in C also. So if you look at like comparison, don't say this one is better than the other one. They're all have great advantages and maybe some disadvantages there, including Bash and awk and shell scripting and everything else. So in this case, we're not going to compare them, because there's no situation of green apple with green apple to say the size is the same, the taste is the same. You cannot do that one. Sometimes even if you compare 2 apples, one is red, one is green, and then one is a different size, different taste, different trees. So similarly with Python, for example, the modules that are available, or C# is available, or Go language, a lot of those things, they already had existing software, and then just they enhance it further. So yeah, the simplicity of Python, for example, how simple it is to learn, how simple it is to write code, and how neat it is, I really like it. But in terms of like efficiencies of performance, assembly language, and C and C++, they're top of the line no matter how you look at it. So let's just go back to our f-test statement in this case, and then we are going to just define some stuff here. And then at this time, I wrote this one and I ran it, and I said, okay, this test statement was looking for it. So now I'm going to say name is equal Wahid. So let's just my short name Wahid here. And if I just say echo $name, in the command line, I don't have to go inside the shell script. I know that variable exists. And then I can also get the braces around it, so to make sure that I can check for the existence of this one. The brace is very important. For example, let's say if I say ftest minus z $name, and then I say echo, echo, and I'm going to just say one more echo. I just should have said, sorry. Here, when you say that ftest, then a statement was missing. So you say echo yes, just for that one, else, and say echo and no. So if I just say that those two words, depending on which one is true, it's gonna say, yeah, minus z $name is empty. It's not empty actually. If I just say echo $name, it is going to say this. And if I say this, so you have to be very careful when you're coding. If you look at this statement, this one returns say no. As soon as I put it within the braces, saying that if this variable is empty, then it says it is not empty. The echo says no, it's actually not empty. So then if it is not empty, I must just say if it is not empty, and then say yes, it is empty. So let's say I'm gonna say yes, it is empty. So this one will not execute, and it says no. So if it is not empty, I'm gonna say no, and then say echo, and this one I'm going to just say $name. So and I just want to do that one. Notice that it says no, it is the variable. So I could just say no right here and say it is not empty, and then just print that one, and it says that message. But notice if I just make this one within the brace, take the brace out on both sides, and now it's going to say yes, it is empty, which is not true. Well, if it is empty, then why you gave me the word Wahid? So my code has to have this one because that string is defined. That string is defined, and then that string is defined, and then is there. So now if I just say unset name, and now I say echo and $name, it's not going to return, and this one is not going to return. So notice that at this time, if I do the minus z with that case, then it's going to come say yes, it is empty. And when I echo it, and the echo did not print anything here, because the syntax of that if statement, when you say then yes, it's empty, and then you could just say, for example, the $name, I'm going to just say, because if I just say $name here, watch, and still is going to just put a not empty string. So in order for me to prove that I'm there, I'm going to just do like a bracket here and say within that bracket, then put it. So now it's going to say, yeah, the string was empty inside the bracket. $name is going to give you that. So you're double checking yourself a couple of times. That was like a checking comparison for the string name. So let's go back here and say .bash. And now if I just say, what if I want to know if this file is readable? Then I could say ftest-r ftest.bash, and then I say, then echo yes, and the file is readable. And then I could do that. I'm sorry, I should have just done the code. And then I say ls minus ld $, not $, this one is f-test.bash, and then else echo no, and the file is not readable. So if otherwise, it's going to just say no, but says yes, the file is readable, and then it's going to run the ls minus l command here, and it's going to do the same thing. So now if I just want to change that one to say if the file is writable, So all I have to do is just go on my statement here, -r for writable, and then say, yes, the file is writable here. And instead of readable, you say writable. And then the second part, else is echo, the file is not writable. Not writable. So not writable meaning that it is writable because the file is there. So what if you want to check for it, and then at the same time you want to do this? So let's say f test dash executable file, and then the name was f dash test dot bash. We say then echo the file is executable. So -x means executable. I'm going to say ls minus ld dollars and the file name f dash test dot bash, and then I'm going to also run it, because when we know that it is executable, then it must be able to run it as well. So then we say F5, because we started with the F statement, we're going to do that one. So now you could see that the file is having that X permission. Read, write, execute by the owner is set, and then read, execute by the group is set, and then read and execute by others. So the file is now read and executable, and then when we run it actually with this statement, it just actually produces this output. So now we could just also check for this one, and then let's say for this one, and we say if the file is readable, and the file is we're going to change it to readable here, readable, and then we say and instead of the ls minus d, the same, and instead of doing this, so since it's readable, we say cat minus n and just look at the content of it. So now we see if test is readable, bash, then echo the file is readable. So it does say the file is readable right here, because this -r it is going to execute that one. And then this other part, ls minus l, is going to just show this one, the file permission, because the the r for the owner, and then the r for the owner right here, the r for the group, and the r for others is showing us that we have the permission. Since I'm the owner, W. Lutfi, I have read permission, so I can look at the content of it here, cat that file. And then now let's see if the file is writable. So if the file is writable, then we could just say, okay, let's just add one more line to that file. And then we say if the file is writable, if it is writable, then the file is writable here, writable, and then we are going to just say ftest.bash cat minus n, and we could do this. We could just, instead of cat minus n to display it, we want to write something to it. We're going to just say echo, just put a pwd on the command, and then at the end of it, just another command like print working directory at the end of that file. So we just line at the end of it. This double greater sign means append to the line number 14 in this case. So now we're doing it, and now the file got modified, if test, and now if I just run it, f-test.bash, in addition to run the actual command, it also run the pwd command. And then if you look at the content of it, line number 14 is added to it, and it shows pwd. So you can dynamically update it there. And if I just want to remove that line, obviously I can go in VI, or I can remove it from there within a grep command. So let me just show you how you could do this one with the grep command. So you could also do a set minus e, and then substitute pwd to nothing from this file, globally and to from this file called f-test.bash and send it to a file, let's say T, for a temporary file, so that this substitute command that I started here set, it should have started here. So now on the T, if I do a comparison and def between f-test and .bash and then the file T, the only line that are different are pwd. Cat -n ftest.bash has the pwd, but the file T does not have it. Notice that T has taken out line 14 because we wipe it out. We can also do a set with the delete /d for delete for that string that we match, and it will do in place on it. And so there's a lot of ways you can do it, and you can also just do a grep -v, for example. So you do a grep -v pwd, string of pwd from the file ftest.bash, and then put it into another file f, and now more f does not have that line. So it is just basically, it's all taken care of. So word count -l f t and f test f dash test.bash, you can see that the f is smaller because we removed it from there. The T is actually having the blank line at the end, and then the F does not even have the blank line. So if I say cat -EA of T, notice that these end of line characters are there at the end of it in comparison to the F file. So the F file does not have it. And then similarly, if I could do octal dump on the file, octal dump -ct, you can see the details that one of them has 2 lines and the other one doesn't have the end of line there. But the rest of the files are all here. Similarly, if we look at the f-test.bash, this one has the pwd and it will show here with the lines, everything. Okay, so a lot of ways you can VI and then do it. If you could do also vim for f-test.bash and go to the end of the line and delete that line and then save it, and it is done now. So now I go octal dump, you can see that it's gone. Cat -n f-test and .bash, it is there. So let's just go back to the test examples and not get out of this looping examples. When I'm teaching you guys shell scripting or Python, I may go back and forth with other examples, because no matter what video you learn or watch, you're going to, the purpose is, the objective here is to learn. When you're learning, don't restrict yourself towards one kind of path. You want to learn it through an easy way, direct way to learn it with examples. The more example you see, the more variation you see, the more faster you could remember things and come back to it and say, oh yeah, that one is not something new to me. I remember I was learning this example and I was seeing this other one that is related. So I know how to grep work, how egrep are said, how awk and how fi or vi or vim or something. It is all kind of intuitive. So some of those similarities, don't be afraid to learn. Learning is easy when your mind is set to learn. And mind is already telling you that, yeah, it's easy for me. I can just do it. And there's an expression that I made on the kind of topics. And yesterday I posted a video, and the video I posted, it was saying something like this. So I'm going to say, just echo the word and say, like Windows, let's say just I put the word like Windows, Linux and Unix is user friendly, and it is selective on its best friends. it is best friends. So this is what the Linux is all about, and Unix is all about. Unix, Linux, Unix. When I say Mac OS X and Solaris, BSD and FreeBSD. When we are talking about Linux, we're talking about a Linux variation of Debian, GNU version of GNU kernel, and then the Linux, Ubuntu, and Debian, and Red Hat Linux, and then CentOS, Rocky, and OpenSUSE, all those ones, Caldera. There's a number of them, and that you can just learn Linux, Ubuntu, Linux Mint, and so on. So for Linux is having the GUI interface that you want to learn, similar to Windows or Mac, that you can click on icons and buttons and do activities that were not available back in the 80s or something. Starting 92, 94, there was a lot of Windows and Accession and GUI, and then the GNOME, and then the KDE, all those information or utilities that were available with GNU software, including the virtual networking computing VNC, or the Tiger VNC, or Accession. All of those ones are actually making our life much easier to just have a desktop session. But on top of the desktop, this shell scripting and bash or SSH connection to the system, you can run a lot of commands and then run it. Imagine with Windows what you can do with PowerShell. In the old days, we used to write batch script .bat, and then now it's .ps1 or PowerShell. And then the PowerShell is giving you so much flexibility, similar to what shell script on Bash on Unix does. So don't be afraid to just use PowerShell on Windows, and because you want to be more powerful, just learn the command line. The command line is there's no restriction how much you can do in terms of multi-threading, multitasking, automation, in terms of running things that everybody else is click. If you have to click on maybe 100 times on something, that's too much. If you have to click 5 times, 2 times per day, that's not much. But if you have to just every day, you're working 2 hours on a system and you're just downloading something, and you have to click 10 times on a particular page in order to get it, and then each subsequent click, it requires another 2-3 click. You could automate it and write a script, and then you could be driving to home, and then by that time, the whole thing is done for you on the automation. Or run it as cron jobs or batch scripting on Windows, or Unix cron jobs or add jobs. And there's a lot of scheduling on Windows as well. With PowerShell, you can do everything. So with the shell, similarly, you can do everything and do. And then with the shells, you're not just tied to the shell scripting or awk programming or C programming or Python. You could just even call the API through some other application that are maybe on the high performance computing, that you're doing some kind of like parameter passing. And when you're calling those ones, you're connecting to Oracle database or MySQL, or to like some MATLAB or some kind of supercomputing environment. Any parameters that you pass, it's much easier if you know how to do automations. And automation is gonna make you senior level kind of admin. So when you're learning Linux and Unix and shell scripting and Python, there are always the 3 different levels. There's in the novice levels, the intermediate level, the advanced level. And the advanced level, once you just get into the advanced level, people know that you're a senior level. And then sometimes different people, they call different type of people senior. But for me, I think the majority of the people, it is not that how many years you worked on a system, it's how efficient you do your job. and how efficient you're doing automation, how much programming you're using in terms of tools and technique, how you mentor other admins that are at the same level that they call themselves senior, how you help everybody in the group, and how you lead the team, how you run the team. And then from at some point, knowing some 5 different programming languages and a lot of different shell scripting, Bash and Python and this and that, all of that one, including the database, the networking, the concept, the terminology, the storage, the infrastructure, Amazon Web Services, cloud computing, all these supercomputing, all of this one is just like a big picture in the IT environment. But making yourself as a senior level, the next level is like, well, you want to be an expert, subject matter expert. Subject matter expert is that if you're looking at the Unix side, it's not that you know Solaris or Linux or BSD or something, and then you say, I'm a subject matter expert. That means on that subject, any application that runs, you're responsible to understand, and you can troubleshoot the like ADB or MDB, and then go to the core files, analyze and troubleshoot things that a senior person cannot do it. If you're working with Oracle database, you don't tie yourself as a DBA saying that I know normalization, I can create a table space, I can work with SGA, I know what a primary key is, a foreign key, a secondary key, all these alternate key, candidate key, I'm very good at them, but you never build the database, you never work on a different environment other than Oracle. If they give you a database in MySQL, you say, I don't know a structured query language or a SQL language. I don't know what a data definition language is or data manipulation language, data query language. Those are the basic building block of a database. So making yourself as a subject matter expert, you have to know around the platforms. You have to know a lot more than just a senior level that knows about the subject. You are a subject expert matter, meaning that if you're looking at Unix, you should be at least a top-notch guru person that you could say, I'm a subject matter on this one, certified, whatever. Those certification doesn't mean anything unless you're actually having experience to set up system from scratch and build it and just make the entire form or configuration seamless to transparent, and there's no outages on you're working on them. So that is just a lot of talk. I don't want to go into too much detail on it, because that one, maybe when I just have a video of telling people how to just get a job interview and pass the job interview as a novice user, as a beginner, like graduating from college, how you pass an intermediate level, how you pass an advanced. A lot of interview questions are not fair at all, because they're challenging you on a question that they don't know the answer themselves. And I would never do that. When I interviewed a lot of peoples, and I always ask question for the subject that they wanted to discuss. So it's a fair question that you ask the interviewer and the person that you're interviewing to say that, well, I'm interviewing you for this job, where's your strength? And then once you concentrate on the strength part, then you can say, okay, you talked about Dockers, can you tell me your area of expertise on the Docker area? So if I question you, I'm not going to challenge you too much if you just started to work on the Docker. And similarly on the virtualization, or similarly to logical domain or zoning on Solaris. So any concept that you're talking about, some thing that we did 20 years ago, like Solaris Jumpstart or Linux Kickstart. A lot of those technologies has changed so much with cloud computing and supercomputing. So you don't want to challenge somebody that what you learned 20 years ago, and then that is not, he's just come out from school and they're doing a lot different. They want to learn Python, they want to learn programming. So those kind of things, I just don't want to get too much. I just want to come back on this one. I think I said it enough. So let's see this video is going to be so long. And then we did the test for those script, and now I'm going to do one further testing, see what is ftest script that was there. And we also want to compare if the file was readable, writable. We checked it. The file size is 0. So if the file size is 0, if I say f minus s, that is f and dash args.sh. So, and then I'm going to say ftest here, and then say then, I'm sorry, the then is mistyped. So then and say, oops, to just go back here and say then, say echo, yes, just nothing else, yeah, else echo no. This is as simple as that, and then say this, and since the no, I did not close it, you just have to start off with this. So it says yes, because the size f arguments, f args.sh, f args.sh is and the file size test-s. So you say man test, and let's see dash s lowercase. I believe lowercase doesn't exist here, and that was what I wanted to do is uppercase. If it is a socket, which is not there, yeah, the lowercase is there if the size is greater than 0. So the file was non-empty, so the test dash s is accurate. If I say if not, and the file is this, then it's going to say no, the file is non-zero. So the size, and if I say disk usage minus sh f dash args dot args.sh, that file is 4 kilobyte. It's not 0. Now if I just say touch this, and then I just say similar command, if I say ftest dash s this, and that's the file, then I say then echo yes, and the file is 0 byte. So then just to prove it, we say this, and then say else echo, and the file is not 0 byte. So it should say yes, it is 0 byte, and it should list it, and that's what it says. It is 0 byte, and then the file ls minus ld, ls minus ld des. The file is not 0 byte, and then the file is not 0 byte, and this was 0 test. So if the file is yes, the file is 0 byte. So why this one that did not return? Okay, so dash s, it means that if the file is 0 byte, and then when I make this one not, then that would be saying the file is yes, the file is 0 byte, because and the file is actually 0 byte. So this test is saying that if the file is size is empty, and there. Again, let me just show that part here, that dash s right here, right here. File exists and has a size greater than 0, non-empty. Greater than 0 mean non-empty, but here the file, this is actually 0 byte. So 0 byte is not greater than 0 this. And then the same thing that we did for the other one, it was there. When you do it minus this, yes, the file is 0 byte. And so this one is saying that the condition, this one is negated, basically. And then now let me just create a file called, so who.txt, I believe, or just who. Okay, the file has like this file called who. I'm not sure what is inside there, but I can just say who and the command, and then write it to who.txt. So let's just use that one. The who.txt, cat who.txt is the output of the who command. And then at this time, ls minus minus LD who.text, it tells me that this file is read-writable. I'm going to make a symbolic link minus S soft link for who.text, and I'm going to call it w.text. Let's call it w.text. Now ls minus li who.text and w.text, they are both having this one is alias or symbolic link to this file. So when I look at the content of who.text or look at the content of w.text, I'm seeing the same file. But notice that this one has an arrow, it says a symbolic link. And if you see the first character of it, this one is saying that it's a symbolic link. This one, it says, is a regular file. So if I just say f test-f who.text, and then I say, then echo, yes, it is a regular file. So this one, I'm going to say else and echo no, it is not. So if I just exit out and says yes, it is there. But notice that if I just do the same thing with that -e, if the file is whether it's regular file or not, if a file exists, that means it's going to say yeah, no, it is not. Yes, it is a regular file. So the no, it is not is coming because the who.text is going to say it is not a regular file because we checked it for the F, but this file exists as a regular file. Let me just look at that one for sure. F test minus E who.text, then echo yes, else echo no, FI. And then it comes to yes because that file exists. And then look at the file of who.text is there. And now I'm going to look at the symbolic link, w.text. This one, you can see the first character is L, it's a symbolic link. Then I say ftest-L w.text. Then we say echo, yes, it is a symbolic link. And then ls minus LD and w.text, and done. FI, not done. So this one, it says yes, it is a symbolic link, and when we list it, it shows it's a symbolic link -L. Similarly, if we do the file, if it's hard link, so if I just make a hard link and say link minus link, if I don't give a -s or just use this link command, it is a hard link. So ln and then the name of the file who.text, and then the hard link, I'm going to give it HL. So now if I say ls minus li who.text and HL, they both have the same inode number. Notice the same inode number because they're just physically two copies of this file. It's not an alias. It's not a symbolic link. This file and that file, they're independent of each other. So if I delete one, it doesn't matter, the other one is there. But for the W, when you delete it, the other file is still there. If you just delete this one, the w.text is not pointing to anywhere because this file doesn't exist. That's an alias, it's a pointer. It's pointing to that address. So, and it has its own inode number. This one is the same inode number. That means that if you delete one, the other one is still available. And if you delete this one, the other one is also available. But in this case, if you delete this one, this file exists and it is going to serve. If you delete this one, the file doesn't mean anything. It's just a symbolic link. Like for example, if I just say rm who.text and then I say w.text, now it is pointing to that one. But if I look at the w.text, it's not going to give me an output because that one doesn't mean anything. It's an alias. Or mw.text is there. So now let's say create that file again and who.text and then link minus s w.text as who and text we created. But now this time I'm going to do some comparison here with one more expression here. that we did. So let me just do man test. What was the expression that I wanted to show you on the file? If it is UT file descriptor symbolic link, I believe it was the uppercase S, maybe. Let me just go back to this one and look at the one that we were looking at, HG-F, and then anyway, I'll just do it, and if I just see it, that I remember I told you that I will look at it and show you. So it was a hard link. Oh, the two files were comparison. So let me just go back one screen here. The file exists as a regular file. And I'm looking at the two greater, this we already checked. And it's this one, EF-EF file and file 2 have the same device and inode number. So the hard link, I'm going to look at the file who.txt with the -EF with whether they have the same inode number. Remember, I was showing you the hard link. So the hard link, clear my screen, ls who.txt, and then hard link, these two files, if I just do with -li for inode number, you see that they are having two different inode numbers. So let me, because I removed that one, so I'll remove that one. Now I'm gonna create a hard link of who.txt again, and then I run this command. Now they are both having same inode number because this one was previously deleted. So now I created the new, I wanna create the hard link. So I wanna just do a comparison. I say f test, the file one is who.txt with EF of HL. And then we say, then echo, the files have same inode number, and then they're also on the same device. So ls-li, li $h1 and who, not $, who.txt, and also h1 hl, and then here we're going to just say fi, and notice it is doing exactly, they have the same file inode number. So another way you can do then also statement, if you don't say the word test, you could still execute these commands and comparison without the test. Let me just show you. So here we did this one, and it shows. I could also say, for example, f $, you could say if test, let's say make a directory, say make dir new dir. So I made a new dir now, ld new dir. You can see it's a D, and that means it's a directory. So you could say f test -d new dir, and then ls-ld $new dir, else echo, and not a directory. So it's gonna list it because it is there. So I made some typo somewhere. Oh, the code. So the code right here where it says not a directory, I started with the double quote, and then I did not close it with the double quote. So that's why it was waiting for me. So it just did the listing. And if I just say right here new dir, and then I say semicolon, echo and directory existed, then you could just get both of those ones and say directory existed. But when -d is there, I could also do a simple way, clear my screen and do this command, and then I could also say f, I could say a simple way without doing anything. I could also say -d and new dir, and then say, go ahead, run the command ls-ld new dir. So this one is going to say, and this condition checking is going to check. Notice I don't have a fs statement, I don't have a this. And then I say this. And at the same time, I could run this command here and say echo the who command, or say echo wahid. Whatever you want to do, you could just add to it. This and run the pwd command and do calendar command. So notice that and as long as these conditions are true, then it's going to just say, if this is true, it's going to execute this command. If this is true, execute this command. It's similar to like whether you put and or put a semicolon. Semicolon is like no matter what, this condition will, and once it runs the first command, it runs the second command. Once it runs the third command, so all of those commands will be executed. But notice the difference here. If I say, if this one is a directory, and then something, this one, instead of and, we say and calendar command, this is all executed fine. But I'm going to just shorten it here and then just have this command. So let's just do this. And then at this time, I'm going to say or say date command. So now it's going to just say, since this command is executed and this one is successfully and this command is executed successfully, this or statement didn't have to be executed there. So I'm going to put the or statement in front of this. And watch, when I do this one, only the dir command, the date command is going to be executed. This is short circuit. The other command is not, is checked. So this command is true and this command is true. So it executed this one. Okay. So, and the or statement is there, but I'm going to just have this command say something that is garbage. It's not true. Notice that the or statement is still short circuit because this one was not true, but this one is going to execute it. So if I just do something like this, this is not going to run because this is an expression saying this has to be true and then this has to be true. So if I say if the file is a symbolic link, let's say, for example, or if it's a socket file, new dir, which is not the case, right? So when you say this one, echo $? Is going to say non-zero. That status is not there. Now, if I just say or do the PWD is going to get executed because this one is false, but the PWD is true. So the or statement, either one of them is going to be in there. So now if I do or date command, that command also going to just run with the PWD is running. So it's not going to do the or of that one because this is short circuit. But if I just do and here, then it's going to say, well, this one was not true, but the PWD is true, and the or statement and also the date is true. So it's going to run these two commands together. And now if I just do as many and as I can do, I could just execute all those statements. Watch if I change that one to an or statement and say calendar -j for the Julian format. And then the Julian format is just also not going to be produced. So let me just make this one calendar 19070. And then notice that 9070 does not come. But if I change that one to and statement, because that combination was there, that 9070 is there as well. So you learn a lot of the expression that you're doing comparison and this and that. So now if I just say if the directory -d new dir1 does not exist, new dir1 does not exist, then I'm gonna say, go ahead and make dir new dir1. So now if I do ls minus ld, new dir1 is there. And if I just say run this command again, the same thing is not gonna create it because already created there. So now if I just do this one, it says the file already existed. I did not do anything. I did not touch it because the command not there did not run. So the end command did not run. But if I just rm dir new dir1, and then I run this command, it is going to still create it. And then let's just do one more command here and say, for example, ls minus ld new dir1, and then do an and. So this one, it says that if this one doesn't exist, then do a ls minus ld, this one is gonna fail. And then let's see if the make dir1 is gonna execute. That should have not executed because we used the and symbol, new dir1. So, and that is the case. Now, in this case, I'm going to say or execute this statement or execute that statement. That's now you say new dir1, it is there. Sorry, ls minus l new dir1, because we did not have it. So if we did not have it, this has to be an and symbol to say go ahead and create it. And then the new dir1, actually this one would be have to be coming after the fact we created. So we say go ahead, if this one doesn't exist, and then make dir, and then do and symbol ls minus l new dir1. This would work. This would just display it, and then ls minus l new dir1 is there. And I'm going to remove minus rf new dir1 and then new dir. Both of them are gone. And that ends our session. I'm going to just see if I have this script here under this other directory. I'm going to run it, peace.sh, and I welcome you back again at MyWebUniversity.com. Thanks for watching our channel. Please don't forget to subscribe. And that's My Web University free education videos. And then love and peace to you all. God bless you all. Have a nice one. Take care.